can anyone tell me the what are the 5 stages of design thinking?
So, okay, sir. Let us start about the brief introduction about design thinking. That is nothing but the problem-solving approach where a problem can be solved in 5 steps. That is empathy, define, ideate, prototyping, and testing. So, okay. So, empathy is nothing but the feeling from the customer's perspective, where the problem faced by the customers are analyzed in this empathy part, and in lot of problems we are choosing a one problem which is majorly affecting the customer side, that is comes under the define part. Is it right? Yes. So the ideate part is nothing but giving some ideas with our hardware and software knowledge, and prescribing the ideas with the project we use, and making a prototype in the basis of the project, and in testing part we are going to test it with the customer's side, and to get the feedback and to evolve the process. So the empathy of this problem statement is in ECG signals we couldn't get a correct output because of noise. So anyone can say what can be the reason for this noise reductions?
Yeah, I have more noise. My muscular noise, muscles are muscle noise, and the wave signals, heartbeat wave signals, it can convert into many noises. Clearly, we cannot get out.
Yes, it's correct point. Due to some internal organs noise, such as muscle pumpings and heartbeat sounds, we couldn't get the clear noise output in this function. So, what can be the main reason for this noise reduction is nothing but to increase the speed and efficiency of a real-time adaptive filters. So, to reduce this, we are going to give this an better idea to the defined part. So, the customer's perspective should be right because many medical errors are occurred due to the noise, due to this noise of heartbeat and muscle pumpings. So, the defined part is going to come next. So, this is the empathy part. Okay. Next about the defined part.
Yeah, we are going to define the part in medical fields. Medical professionals requires a real-time, reliable and low latency solutions. Anyone can say what is the meaning of latency?
Latency is nothing but speed of adaptive filter. It is based on the efficiency and working of it.
The latency plays a major role in the reducing and removing the noise from the ECG signals, especially the portable monitoring systems, which are majorly used by doctors and some medical professionals. To ensure accurate diagnostic ECG signals and efficient treatment, we are going to use noise reductions in ECG signals.
So, okay, this is the defined part. So, on this, you said the word portable. On the earlier times, we don't have the portable. So, it is currently reduced by the DSP, digital signal processing. So, to increase, we get some errors on these also. So, to reduce this, we have got a defined part, that is latency, speed. The speed of the ECG signal should be increased. So, the ideate part is next. So, the ideate part can be defined.
So, I am share the ideate part, like brainstorming potential solutions, adaptive filtering techniques for real-time applications, and the comparison between LMS and complex analysis like RMS, and implementation of low-power DSP signals, and the integration with the IoT-based monitoring system, and auto-tuning of LMS-based different noises tuning system.
Can you tell me what are the difference between LMS and RMS?
Sir, in LMS it is the basic model, sir. So in LMS, on the earlier days we use this least mean square. So in RLS is an upgraded version of this LMS and NLMS. Okay. So what I'm trying to say that in LMS we have got some error. So in this I'm implementing the DT based approach. The upgraded version of NLMS and the upgraded version of LMS is nothing but the RLS. So now in RLS also we have an upgraded version such as parallel piped LMS, which is now currently used in adaptive filters and ECG signals. So the ideate part is clear now. So he said about the algorithms we use in this adaptive filters. So next, the prototype and ideate part of remaining. Can you explain?
Yeah, prototype products. And ECG signals have more noises. You clearly said ECG products most noises. And it has rectified by a stethoscope. A stethoscope has not much noise like ECG signals. We have noise here clearly or any other ways. Those also have muscular noise and organs all noise those all have. That are asking the low input to higher input. The stethoscope as we have give small input, it have increased 1000x or any other it will give much other. Why your ECG is not correct output? It has our body, we have all other organs, we have converted into signal waves. It has more complicated to or complicated ways like using. In analog signals or converted to digitals, the signals will be some noises using in ECGs, and it can implement in biomedical fields, and it can customize as a math lab using math lab and Python code. And using nowadays fully playing a role in embedded and DSPs have the signal waves and many other waves.
So okay, he said a nice point, that is, he said about the hardware points of this ECG signals. You said about the software points of this ECG signals. So here we come to know about this is nothing. This is comes under both hardware and software. So the next about the he said about the stethoscope. The stethoscope is used for only using in a single part, but ECG is totally different. It should handle the all body organs in our body. So we can hear more noise and more errors in this project. So we should rectify it with the parallel pipe LMS, as he said before. So the prototype has been explained. The testing part and outcome of the customer's feedback can be explained.
In testing part, we evaluate the signal to noise ratios and the mean square errors before and after filtering to improve and system latency and real-time performance. We get feedback from cardiologists and medical technicians for filtering ECGs, and we refine the optimized step signals to balance the speed and accuracy, and explore the hardware level of the filtering ECG.
Okay, nice. Anyone give conclusion of this thing?
Then now we are going to see outcome part. LMS filter is using to diagnose the heartbeat ECG signals in nowadays. Now the parallel pipelines are used to diagnose the heartbeat rates. Then we are going to move next level sensor in future. It's ready to go evaluate the medical fields. Thank you.
Thank you.